So in this session, or in this part of this lecture, we'll create an array of the sessions that I have for my courses. So in the first part of the lecture, we learn how to manipulate a string by computing string length. In the second part of the lecture, we learn how to write code that works with an array of addresses of strings, and that's how we compute the max length. That was the maximum length of the name of any student in a given session of a class. But now let's suppose that I have several different sessions. In tutorial, for example, I have two, but I could consider all the course sessions for the entire Department of Computing Science, for example. That could be a long list. And let's suppose that I have organized the name of the students in the fashion that I said before. And so I have these arrays with addresses that are the address of the names, the first character of the name of the students. And what I want to do now is, so what I had before was an array with the address of the first character of the name of each student, ending with a sentinel value. And in the example of tutorial 9, I have two of such arrays, one for the morning class, one for the afternoon class. What I would like to do now is to have an array of the addresses of those sessions. So what I mean is my new array that will be somewhere else in memory. The first position of that array will be the address of the memory position where the first session starts, or where the list of the address of the name of the student starts. And the second position of my array will be the second session, and so on. And when I'm done with the array, I will have a sentinel value of -1. So let's see how I can make this work. And first, let's see what's happening here. Let me make myself smaller and up on the corner. And so the first thing that I have here is showing that the first position of this array of sessions points to the first position of the array of string addresses. And then the first position of that array points to the name of to the first character of the name of a student. The next position of the array points to the character for the name of the next student, and so on. And then the second position of my array will point to the first student, or to the address of the name of the first student on my second session. And each one of the positions of that array will be pointing to the first character of the names of the students in memory. So this is the data structure that I have, that I wanted to operate with. And I want now to have a function called summax. And summax receives as a parameter the address of a list of classes. So summax will receive, for example, 0x1003ff00. That's the address of the first session, and then I will have other sessions after that. And the return value for summax is the sum of the longest names in each session. So for each session, we're going to obtain the longest name, and then we're going to add the no-op, and that will going to be the return value for summax. So let's look at the code for summax here. First thing that I want to note is that summax receives a parameter that's char star 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 s. So this is a pointer to a pointer to a pointer to a character. So if I look in my data, this is s. So s is a pointer to a pointer to a pointer to a character. So you can see that this appears very naturally when you start organizing data in this fashion in memory. So I'm going to start by initializing my sum to 0. And then I will load the value from that address that was given to summax. So let's assume that summax received this address 1003ff0. So I'll load the value that's in there. I'm gonna get the value 0x103000, and I'll test whether that's my sentinel. If it's not my sentinel, I'll take that value that I just loaded and I'll pass it to maxlen. And that's exactly what maxlen expects. Maxlen expects the address of the first character of an array of addresses. And I take the value that maxlen returns to me and I'm going to add to the sum. And then I'm going to increment my pointer. Incrementing my pointer s will move from this, in this example, from the position 1003 FF0 to the position 1003 FF04. And then I'm going to return the sum. So let's look at the assembly code for sumax. First, I would like, just like what happens in maxlen, I'm going to make a copy of A0 into S0 because I'm going to need to change A0 to invoke maxlen. I'll initialize my sum to 0, and again, I'm using S1 because I will do a function call, and the function call would be changing my T registers. And next, I will initialize my sentinel, that is S2. And next, I'll load the value from 0S0. So S0 currently contains this address here. So loading that will give me the address 0x10300. I'm going to ask whether that's the sentinel. If it's not the sentinel, then I will simply invoke maxlen because I already have the address of the first position of my array into A0. Maxlen will return the value of the longest string, and I will add it to sum. I'll increment my pointer by 4, and then I'll load the value of 0S0 into A0 again. This way I can test again. So I'm using that technique where I have 2 tests for the sentinel, and that is so that I don't need to have an extra jump inside the loop. And so if it's not the sentinel, I go back to repeat the loop. And in the end, all I have to do is to copy the value, the sum into A0 and return. So of course, this code as is would be incorrect because it does not follow the register calling convention for RISC-V. I am missing the save and restoring S register and array that I need to do at the beginning of the function right before return. I'll leave that as an exercise for you to write that code. So now that we understand the motivation to have this array of addresses, in which each one of the addresses pointers to another array of addresses, in which each one of the addresses points to a character, let's look at the types that we have here. So clearly, this V is of type char. And this value here is the address of a char. And the value that is inside this memory location is a pointer to a char. And the address of that pointer is the address of a pointer to a char. So this address that's inside this memory position is a pointer to a char, because this points to here, and here I have a pointer to a char. And this is the address of a pointer to a char. Okay, so I think that should be clear. We start with the char, we take the address of char, this becomes a pointer to a char. We take the address of that pointer, that becomes a pointer to a char, and then we take the address of that pointer. So this value here, if I use that as a pointer, would be a pointer to a pointer to a pointer to a char. How is this expressed in C in terms of types? So that was a char. This address here is char star. This is also char star, it's the same value. But this value here will be char star star, because it is the address of an address of a char. And this also be char star star, and this address here is char star star star. So so this is an example of how we can use this series of arrays to create a very useful data structure. And what I like about this lecture is that it shows to you very naturally how you end up with pointers to pointers in C. And I hope that this three parts of this lecture will help you better understand pointers in C.